So, describing statistical variance from post data. So, just as many of you platforms have become available, generate a single run and enter the genome sequence individual human genome about 10x, and this sequencing is only going up. The newer versions are the high-seq promises put. Additionally, we single run using a barcodes. So platform 296 a massive sequencing and ability to sequence us to sequencing. Why we are interested in that is because it can association series where sequence that have wide association studies or disease genes identify rare and variants that type. So in order to do this, we need to sequence have enough statistical power to detect, and the limiting factor is the cost of capture, which can small and even exceed. And just to give numbers, at a $200, you need to spend about $1,000 just for entire capture can be DNA approach idea simple. So from people individuals and you pull them DNA from individual to form a sample, and one has a single sample. And so this is more of sample the single run. You have papers that of sequencing. So science. Last year, the price of 10 4 and there are other papers identify population sequence, and the technical show that when you pool contains equal, when you see the pool, you don't have any biases. You also want to make sure that you don't any particular sample. And from the side, main lens is to detect the rate surviving false positive, low false negative rate, and the real frequency, which will allow you to compare these and find the functional. And today focus on this detection of real sequence data. So there's a girl that just try to illustrate it is where from sensing we have just a similar two positions in a sequence, and we have a over this pool, and position one led to position two variant. The allele cross position one that about how this have the non reference, while at position of 100 reads have just because of sequencing error. At least in this example, to still as present sample the difference between individual, and so enable redaction the allele 50% or 100% in a log, and efficient number of times you can distinguish the vary from sequencing errors, and you can also the reduction is close to or close to 1. This is a full thing, the allele frequency variant allele. So if you have a booger pool, you have a rare allele, and as I showed on the previous slide, much more difficult errors, and furthermore get information, get an estimate frequency. So there are methods proposed for this problem for variants, and notably them snips in the methods paper and standards some limitations. So design datasets and do not design from a single pool, and they do not look at multiple to very accurately. And as I will show later, there's a lot of information you can get by looking at multiple pools. It's a limited analysis of the accuracy of these methods. So I'm going to describe this method, which acronym that is a critical method for using information from multiple DNA to identify rare and common sequence variants, and the method is to variation in read times and sequencing error rates. It can the number of pool and the depth of coverage for each pool. So before I describe the algorithm, I just give you a brief overview of what this of sequencing and variant detection looks like. So the first step, if you reference multiple individuals into a single pool, from this pool D you can do sample prep or target capture sequencing line, which can be sequenced using any sequence forms, and from this sequencing the sequence which align to a reference genome, and the find of a sequence read for multiple pools by K. Each pool contains DNA from and so our algorithm from this point where the line sequence reads. And so just to illustrate the algorithm, I use this notation where all the reads that cover the genome can be or represented as the alleles. So the white circles represent reference, circles represent non-reference alleles, and we'll have expression that the base quality value, the of the read line, and the number for of information you have to detect variants. So method uses different ways. First strategy to use is to compare the count across multiple pools to identify for this table analysis. P-value the presence of variance. The is to identify common variants. Looking for the success of non-reference alleles in each pool, and for the base quality values shut to view up. And third, finally, we also use about number of individuals to filter false rare variant. So by one. So the first statistic is based on allele count across multiple pools. We have 4 pools, and each pool of information present calls at pools in the genome sequence. So here we see you have these black circles that represent non-alleles. So in the case when you don't have a variant in one of the, you expect to see that all these black circles represent sequence and are more or less randomly distributed across the pools. So you don't expect to see one pool with a number of black circles and other pools with no circles. And in the opposite case, where pools have a rare allele, what you see an excess black circle, not space calls in the pools. Just the intuition behind this, intuition. So we the cross multiple pools. The contingency table you have corresponding to the number of reference or represents up. So for K table and the intuition to this contingency table, in the sense that if you have this contingency table, is likely means that this table will have a high in count when you have a rare table expected to be like with low p-value. Table, so basically define the probability of table, same row and columns as the table probability to given table. So it's because that are more table, and if you didn't speak third, you can use. So I could test many of the problems used to compute 2 by 2 tables can also be used, and however this test is not appropriate when 0, which is the case in many of the in the absence of a variable 0, and U is what's the known as the fact test. Exact value the computing time of this that you examine grows exponentially. Thirdly, you can use a Monte Carlo strategy, example random contingency tables, and compute tables that at least extreme as the observed table. Kind of p-value, how p-value is limited by the number sampling, the sample you can rate. So for our, we've implemented the exact described by meta in 9 cursive formulation X is the p-value 2 by k tables with k1 k -1 columns. And algorithm grows k and also in the table. This approach not so therefore handle the Monte Carlo algorithm that computes the simulating random use these two strategies to compute the p-value table, the size, and the end table. So the second use is to look for the presence of an excess of alternate. So the intuition being if you if all of black alleles should respond to sequencing error, at least approximately the sequence rate and if you see the number of alleles are the error rate of the coverage that the event in this pool, and for the computing hypothesis, the index to estimate probability of a given number of alleles and total alleles, and we use a chain bound probability, which gives us a probability implied presence of a variant allele. So find the price filter false variance maybe two strategies may not be filtered out. So the idea being pool that has haplotypes, and allele frequency of a certain allele is expected to be approximately. So see, and this number is represented maybe 75%. You may have bias of coverage. So however, you not too much below that. So what do is value for observing out of n alternate allele in the presence of variant, and that when you have n is 100 and number of haplotypes, you can only observe two p-value, and as the p-value goes, and use this test, we actually filter out variant low p-value. A low p-value indicates the presence of a variant. So now to use the different form complete the method. So we have for each computes the based value k and computes the p for pool, and if of these p-value value for the bound base below a certain threshold, we perform the p-value for a pool is greater than as a variant pool. If doing of this test, you identify the position as the algorithm. Now some results. So we use data to evaluate how our method was obtained by the sequencing of 109. That was the DNA was captured and sequenced the pools of 20 samples, short reads, and also we also data 50 individuals that sequenced as well. So there the sequence variant on the pools, two variant calls, coverage in the pool. Was here we had 4 individual pools with the DNA tag a unique part. So we could take calls each individual set calls, and coverage in this was slightly low. So for first dataset, Chris identified about 65 to the equal calls, found that about the individual calls. So recovery rate 6%, 90 snip per call individual identified from the data. So we investigated this, that 4 of them had to one individual, which was presented in the 75 were residents, which are the most. So, these 3 explain a lot of the false negatives. The method has 10 to 50%, but which can average and by storing that each individual in the pooled DNA. About 545, and 19 of them were them individually because there's no positive rate. Set we look to see how complementary statistics that are used for the contingency analysis, which the intuition, while quality analysis was designed written was when we looked at the number of using these 2 methods. In this have and method are presented by to the quantitative approach was more powerful singleton and rare variant. So intuition we had was developing method where our previous method we applied methods to the processing data to defects, and with that both those data crisp and false negative even at the default really by the stringent. That one reason for is that method used from the multiple pool have variation of a single pool. So just to size, I to you the general for detecting variation of multiple DNA pools, and it uses 2 clear and common variants and error rates implemented in the Python and available, and it accepts start from line reads for lines in the standard SBAM format and outputs that's processed by 1,000 genomes project. And finally, some going the PV behind this will be able to use pooling and action sequencing to large sequencing studies. So recent pilots have map to show that you can use existing target captures to actually rate from and also try to how to design the pools, what kind of should be the maximum size of a pool, and whether you should individual in one pool or multiple pools to maximize our text. And we also there's also the tricks that I've used they out any values, so I want to put maybe a formal strategy for combining those multiples to variants, maybe improve the detection ability. And acknowledge my supervisor and the thing at Genomic Medicine who generated all the sequence data used in this.
Get started that how you can do that
Yeah, so if you have data from that have different error rate, then the method will have a higher false positive rate. But for it's better to use this platform and the machine with similar, but with more rate, it wouldn't really affect it. But I haven't really like how it's the error rate effect.
In statistics 1 for real variables, table statist for
That is cool. Here we do for statistic, we throw a quality score and give some simple solution. If user decrease showed how the false in the statistic changes, it's much than second the the quality value.
Just wondering, we also got the local boundary of the aligner, which is one thing spits out in small regions like and give you
Yeah, so if you have so there are some extra features that I didn't talk about. So if you have that kind of design to filter out false variants that could be artifact in cells, and we require at least 3 regions with a pool, and all of them shouldn't be towards the end, and that actually can also detect indels. So if you find a flow to an indel, you can figure out.
Thank you.
Going to use strand information in your future because experiments show that taking account strand information numbers is
Actually, I didn't mention it, but the third statistic one where you fit the variant use value by binomial separately for 2 strands. So if strand has high error, other than will have value and the variant will be.
Have groups. If you can use, you have full pools for one type of to prove it. In order to look for that, that would be it rather than this pool.
Well, I mean, this variant. I mean, with the variant goes that after you want to detect variant, so at least you may be able to pick variant, not at the same cross all. So that's only like kind of just built into that you have.